Okay. There were three girls standing in a circular pattern. One is Reshma, one is Salma, and who is another one, beta? Is it Mandeep, right?
Yeah.
Mandeep. Okay. These three are playing a game by standing on a circle of the radius 5 meter. So what is the radius of the circle? AO is 5 meter, right? They have given it. Then the Reshma throws a ball to the Salma, Mandeep to Reshma. Then if the distance between Reshma and the Salma is 6 meter, this is 6 meter, okay? Then what is the distance between Reshma and Mandeep? So we're going to calculate what is AC. AC is equal to how much? So to calculate AC, what we're going to do is let's take MO is equal to X. Let's take MO is equal to X, correct? What did we do? MO is equal to X. And what else, beta? AM is equal to Y. Did you not consider AM is equal to Y? Okay.
Yeah.
If we draw OB, what is OB now? Is it not 5 meters? Yes, it is 5 meters because it's the radius of the circle, right? OB is 5 meters. And what is BM now, beta? Is it not 5 minus X? BM is equal to 5 minus X, right?
Yes.
So we have these many points. So BM is 5 minus X, OM is X, AO is 5 meters, and AM is Y, and AB is 6. So if we consider these two triangles now, let's consider these two triangles now. Let's erase all of these down. Let's consider the two triangles and apply what are we going to apply, beta? Which theorem? Pythagoras theorem, right? What does Pythagoras theorem state, Laiba? What does Pythagoras theorem state, beta? The hypotenuse square is equal to adjacent side square and opposite side square. So if you apply Pythagoras theorem in triangle AMO and the triangle AMB, let's apply Pythagoras theorem to AMO. How will you apply this, beta? What is the hypotenuse in AMO? Is it not phi square?
Yes.
Yeah. Phi square is equal to y square plus x square, correct?
Yes.
AM is y square, MO is x square. So this is for the first one. What about triangle AMB, beta? Is it not 6 square is equal to y square plus 5 minus x whole square? Very good, very good. So to get just the x, what did we do? We are writing this equation 1 and equation 2. Let's just minus 2 minus 1, okay? Let's just do 2 minus 1. What it will become? 36, right? 6 square is 36 minus 5 square is 25. 25 is equal to, what is this? Y square plus 5 minus x whole square minus y square minus x square. So x square cancels out plus x, sorry, minus y square plus y square cancels out. And when this 5 minus x whole square is split at what it becomes, beta? Let me raise the upper things. Have you understood till here?
Yes.
Yes, so this much is understood. Very good. So
11 is equals to
35, 36 minus 25 is 11 is equal to 5 minus 25 whole square. Is it 25?
25
minus 2 into a into b. 2 into 5 is 10. 10x. Very good. Minus 10x plus is it x square? Yes. Yeah. Minus x square is outside here. X square minus x square cancels out. So 25 minus 10x is equal to 11. What does x mean? So 10 is equal to 10x is equal to 25 minus 11. Correct, beta?
Yes.
Now, again, 10x is equal to, what is 25 minus 11? Be quick. What is 25 minus 11?
14.
Is it 14? What is 14 over 10?
Oh. So 7 by 5.
It is 14 over 10. 2 7 times is 14. 2 5 times is 10. So x is equal to 7 by 5. Please write this down. Have you found out x?
Yes.
X is found out. Now just apply the value of x in any of the equation 1 or 2. Please apply the value of x in any of the equation. Where will you apply, please? Will you apply in first equation? 5 square is equal to x square plus y square?
Yeah.
Okay, what is the value of x, beta? Is it not 7 by 5? We have already found out.
Yes.
7 by 5 whole square plus y square is equal to 25. So we are going to just find y, okay? How are we going to find y now, beta? 25 square is, 5 square is 25. Let's keep it as it is. Again, what is 7 square by 25? Let's put it this side. So if we'll send it this side, it will become 25 over 49. Is it right? Yes, yeah. Correct? This is equal to y square.
How did we get 27?
5 square.
Oh, okay.
And 7 square? Yes. Understood? Or else let's keep it in this way. 25 is equal to 49 over 25, correct? Plus y square. Is it not correct? 5 square is 25, right? 7 square is
Yeah.
29. We have to apply whole squaring, right? Right, Laiba? 7 square
Yes.
over 5 square it becomes. 49
Yes.
over 25. Now it is moved here. 25 into 25 over 49 is equal to y square. So what is y? Y is nothing but root of 25 into 25. Can we not write as 25 square? Over for 79, what is it? 7 square. What it becomes is you can squaring, you can take it outside to square, then square and square root cancels out. So y is equal to 25 over 7. Okay. What is 25 over 7? Can you just split it into a smaller thing? Can you just do something else for this? Is it 25 over 7, beta?
Yeah, I can't do
Yes.
anything.
Any doubts until here, whatever you have studied?
No.
All
No.
right. So 5 squared becomes 25. It moves here, 25 whole square. Is it squaring? Yes, it becomes 25 squared. Divided by 7 squared. This is 7 squared. 25 squared divided by 7 squared. And the whole of the root, which becomes 25 square root square, 25 over 7. It becomes 25 over 7. Okay, that's great. Okay. Y is 25 over 7. How will you find the rest of it? Please write the rest of it. What you are going to find, beta? Is it not AC? AC is nothing but 2 times the y, right?
Yes.
Just multiply it with 2. What is 25 into 2? It is 50 over 7. This would be your answer. Let's check whether this is an answer. You just have to do what is 50 over 7. 7 1 times 7. How many times is 50? And you're going to calculate the point part. We'll see what the point say it takes. You can just calculate in the calculator. Okay. We'll just move to the next part, and we will revise this one after we are going to see the problem number 6. Okay. Let's just go to the problem number 6. Okay. We're going to start here. What is this problem stating, beta? Come on, read this problem for me.
A circular park of radius 20 meters is situated in a colony. 3 boys, Ankur, Syed, and David, are sitting at equal distance on its boundary, each having a toy telephone in his hand to talk to each other.
This is Ankur.
Find the
A
length
is
of
Ankur.
the
Let it be
string of
Ankur.
each phone.
B is let's write B as Syed, and let it be yes. Okay. What about C? Let's write it as David. Okay, instead of C. This will be easy for us then. Are sitting equal distance on its boundary, each having a toy telephone in his hands to talk to each other. Find the length of the string of the each phone. So what they have told is find AS, find AD, find ESD. Okay, find AS, find ESD, and find AD. So what is given? Only the radius is given, live. Okay, radius 20 meters given. O to S is given. Okay, beta. It is the only thing that is given. Anything else is not given. So what we are going to find is this one. AS is how much, AD is how much, ESD is how much. Let's keep it as X, okay? Let's keep all of this as X. It is same as the previous one. We are just going to apply the Pythagoras theorem to this, okay? Okay?
Yeah. Yes.
Let's just calculate something here. Can we not write? Okay, what would we take here? A, yes, yes, O, okay? Yes, O is here. Okay. So what is OS? What is OS equal to? Is it not the radius? OS is radius, right? O and it's O to Syed is the radius of the circle. It is given. Is it 20 meters? This is a new construction that we are going to make. Is it the radius? What is it equal to? Is it equal to 20 meters? Yes, this is the only thing that is given. Correct? Correct, Laiba?
Yes.
Yes, right? Okay, that's great. So what do we have here? Do we not have that? Where is yes? Okay, this is yes D. Okay, let's keep this as a B. Let this be A. Let this be B. If we write what is this yes B? Is yes B is equal to BD? Is yes B equal to BD? Yes or no? Just tell me whether yes B is equal to BD. This is yes, point yes. This is D, okay? Is yes B equal to BD?
Yes, yes.
Yes. Why is it so? Because we are going to, this is a perpendicular, right? Perpendicular drawn to the chord, yes B, yes D. So yes B is equal to BD. So what is it actually equal to? Is it not half of the whole yes D? Yes?
BD is half of SD.
No. The total ESD, yes. BD is half of ESD and even
Yes.
ESB is also half of ESD, right? Both of these are
Yes.
equal to half of ESD. So instead of, why are we writing this? Because we want to get something called the whole of this, right? Whole of this theorem. Instead of writing the small thing, we have to write half of something, right? Half of ESD.
Yes.
So to calculate the whole part, we're just going to use this ESD as a notation here. Instead of ESD, can we not write X? Because SD is equal to X, we have already taken ESD, ABS, AS, and AD. Let's take AS is equal to SD is equal to DA is equal to X. Okay, this is considered already. Okay, because we have told that the telephone string is same to same. Okay, this is an equilateral triangle, so all is X. Okay, first we are going to consider that it is X, then it is 20 meter. We know this, and instead of SD, we can write half of X, right? So instead of SB, we can write half of X. Instead of BD, we can write half of X. And instead of SB, we can write half of X. So now we are going to consider the triangle. Let's consider which triangle do we want to consider, beta? To prove the right angle thing. Which triangle can you consider? You can consider which triangle here?
SOB.
Yes, OB also you can consider. And even another thing you can consider here. Can you not consider ABS? Let's see if we can consider triangle ABS because we have something called, okay, we'll see what we have, okay? In ABS, let's consider in ABS, what do we have here, beta? Do we have this one is equal to 90 degree? Angle ABS is equal to 90 degree?
Yes.
Yes, right? So to prove this one, can we not take the Pythagoras theorem? Please tell me what is the Pythagoras theorem. Are you writing all of this down? Written? This is written?
Yes.
This you have written? ABS is equal to 90 degree, you have written?
Yes.
Triangle ABS, what is equal to 90 degree? Angle B is equal to 90 degree, right? Yes, angle B is equal to 90 degree. Please write it till here. Done?
No, right.
First write AS is equal to SD is equal to DA given. So let's consider it as X. First thing you have to write this. Then OS is equal to radius is equal to 20 meter is given. Correct? Then let's consider SB is equal to BD is equal to half SD. SD can also be written as half X. So instead of SB and BD, we're going to write half X. Okay. And then we have a triangle ABS, which is equal to angle B, which is equal to 90 degree. So here we can consider in the triangle ABS the hypotenuse theorem, which is the hypotenuse theorem. It is nothing but the Pythagoras theorem, right? Is it not the Pythagoras theorem? Yes. Done? Written? Should I erase all of it?
Yes.
Okay, I think I have left some space here. Yes. Okay. Let's clear this down. Okay. So we have angle B is equal to 90 degree. We know this. So can we not consider in the triangle AB? Okay, instead of B, we had taken yes because it is Sayed, and instead of this, we have taken BD. And let's take this BAB, let this line be AB. So this is X, and this whole is X, and this is half X, and this is half X. Correct, beta? This is quite easy now. Next thing is this is 20 meter, right? This is 20 meter in length. Now we have the whole of the triangle. Whole of the triangle, let's consider this triangle. Let's write the Pythagoras theorem for that. A square is equal to, we are considering the triangle ASB, okay? ASB, consider the triangle ASB. And which A square is equal to, what is it, beta? Is it equal to SB square plus BA square? Yes? Hypotenuse A square is equal to SB square plus BA square. Is it? Where is AS? Lab, I cannot hear any response from you. This is hypotenuse, right? This is 90 degree. The opposite thing to 90 degree, this is called as hypotenuse. X square, right? It is A square. A square is nothing but, is it not X square?
Yes.
Yes. X square. What is SB square? Where is SB square? Instead of SB, can we not write half X?
Yes, half.
Yes. Half of X whole square.
Yes.
Can we write this in this way? Half of X whole square. Plus, what is BA square? BA square is not given, right? So let's write BA square as it is. So we just move this side. Let's move all of this over that side. So it is X square minus Squaring this, how it becomes 1 square, 2 square, x square, right? Squaring comes inside. So it becomes minus 1 by 4 x square, right, beta? Is equal to
Yes.
a square. How will you solve these two equations? This is 1 here and this is minus 1 by 4. You have to apply the LCM. 1 minus 1 by 4. How will you solve this down? It is nothing but 4 minus 1 by 4. Is it? We'll move this side. 4 into 1 is 4. 4 minus 1 is 4. It is 3 by 4. So this fraction goes to 3 by 4 x square. Is it? So what is BA square? BA square is equal to 3 by 4 x square. Please write this down. Is it understanding? Have you understood this, beta?
Yes. Yes.
BA square. Sorry, it's not BA square. Is it BA square? Yes. We want just for the BA, right? Can we not root it out? Root 3. What is root 2? Root 4? Is it 2? 2. Correct? X square will go out. So it becomes root 3 by 2x. Is it right? Understood or not understood? I'll just explain to you again if you did not understand. No?
Yeah, I understood.
Yes, it is root 3 by 2x is equal to BA.
How did root come?
Okay, I'll tell you. Okay, this is the answer, beta, what we got. BA square is equal to, what is the answer we have got? BA square is equal to 3 by 4x square. Fine?
Yeah.
But we actually want BA, correct? So let's apply the root for all of this. Root 3 by 4x square. If you apply root, then it will be root for each one, right? Root 3 by root 4 by and root square. A root and square cancels out. Root 3 remains same. What is root 4? It is 2. So it becomes root 3 by 2x, correct?
Yes.
Understood now? So B is equal to, write this down, root 3 by 2x. Okay, this is the B. Fine? Okay, then written? Have written all of this?
Yes.
Okay, that's great, mashallah. So I'll just undo all of the screen so that it will be easy for me to remember. Okay. Watch each step. Have you understood each of the step? You can stop me wherever you want me to stop, okay? It's quite easy actually. You might find it difficult while solving. At the end, you will see it's just this you have done, okay? At the end, and you will say, okay, it's just to find this, you are going to do this, right? Okay, this much is understood, mashallah. So now, so what we have got now, beta? Did we get AB? Did we get AB? What did we get AB as? Root 3x by 2, right? Yes?
Yes.
Yes. Now, do you not know what is AB here? Is it not AB is equal to AO plus OB? Yes? This is B, beta. Correct? This is B here.
Yeah.
This is AB. It is AO plus OB. Now, what is AO? AO is the radius, right? O is the center. AO is radius. What is the radius of the center circle again? It is 20 again. Correct? Plus, what is OB? OB, do we know OB? Do we know OB? No, we do not know. Do we know AB? Yes, we know. What is AB? It is root 3x over 2. Correct? So, what does OB stand for now? Is it OB is equal to root 3x by 2 minus 20? Is it right? Yes, beta, is it right?
Yes.
Yes. OB is equal to root 3x by 2 minus 20. Just we are going to drag this here. OB is equal to root 3x by 2 minus 20. So we are just going to find OB to apply it in the Pythagoras theorem. That's all. Understood? Till now, what procedure did we do is we are going to find what is OB. Okay? This is what we have found out. What is OB now? It is root 3x by 2 minus 2. Now quickly apply the Pythagoras theorem by taking this small triangle. Okay? It is very easy. You're just going to find the value of x now. Can you do it? Or should I do it for you? Have you written till now whatever I have told? Yes or no?
Yes, I wrote.
Yes. So what is OB? It is nothing but, OB is nothing but, okay, let it be Sayed and this is Ankur and this is David. So What is OB? It is nothing but, what did we just find, beta? It is root 3x by 2 minus 20, correct? This is, what is hypotenuse here? It is 20. What is this one here? Half x. So we are going to apply hypotenuse theorem, Pythagoras theorem, and the triangle SOB. Now we'll see the triangle SOB. How would we apply the Pythagoras theorem? Is it OS square is equal to SB square plus OB square? Yes or no? Yes, right? So what is 20 square? It is nothing but 20 square is equal to, oh, we can just write it as a, okay, let's write it if you get confused. OS square is equal to OB square plus SB square. Okay, it is 20 square is equal to root 3x by 2 minus 20, right? OB is nothing but root 3x by 2 minus 20, right? Whole square plus x over 2. It is nothing but half x, right? Half x whole square. Okay, now solve this down. You will easily get the answer to x. Do you want to do this or should I do it for you? Can you please tell me the answer by solving it in your book? It's quite easy. Do you want me to help or should, you'll do it on your own? Should I help you?
Yeah.
Okay. So what is 20 square beta? What is 20? 2 times is 4. Double 0. Is it not 400?
Yes.
Yes. So we have root 3 by 2 whole square. So this is which one? Which formula will you apply? A minus B whole square. A minus B whole square is equal to A square minus 2AB plus B square. A square. Let's just consider A here. What is root 3 by 2 whole square? Is it not 3 by 4 x square? Yes or no?
Yes.
Yes. A square minus 2AB. Where is 2 into A into B? Where is 2? Let's consider 2 into, what is A? Root 3 by 2. What is B? It is again 20. So 2 cancels out. Root 3 into 20, it becomes 20 root 3, right? So it is 20 root 3 x to AB. By 2 is not there, right? By 2 is there? 2A into B. 2x 20. No, by 2 is not there. 2 cancels out, na beta. Only 3 root 3 into 20 remains, okay? Next, plus x square by, oh sorry, next, what does it give? 20 square. What is 20 square? Is it again 400? Yes, it is 400. Understood? A square minus 2AB plus B square is done. Okay? Now, what is 1 by 2x whole square? It is nothing but x square by 4, correct? Understood or any doubt still here?
No.
No. So this is the equation you're getting. Now for this equation, 400 in this side and 400 this side cancels out, right? So it becomes 0 here, which is equal to 3 by 4x square plus 1 by 4x square. Does it not give you 4 by 4x square? Yes. So what is 4 by 4x square? Is it not 1? Yes, it is x square. It is just x square. 3 by 4x square plus 4 by this one, beta. X square by 4 and 3 by 4x square gives you 1, okay? So 1x square minus 20 root 3x. This is your answer. So what is x squared? X squared is equal to 20 root 3. Is it x here? Should we write x here? Yes. Okay, x squared is equal to 20 root 3x. So what happens here? 1x and 1x cancels out, okay? So what is x? X remains, x is equal to 20 root 3. This is your answer. This is your final answer. Understood or not understood?
Yeah, understood.
Yeah, it was quite confusing to solve each of the step, but if you solve it with very concentration, you will inshallah get it easily. Okay. Please write each of the step and then go through it. And if you have doubts, then you write it. Okay. Tell me if you have any doubts there. Have you written all of it down?
Yeah.
So this is x squared and minus 20 root 3x. So 20 root 3 moves that side. So it's x squared 20 root 3x. 1x and 1x cancels out. So it becomes x is equal to 20 root 3. This is 20 root 3 meters. Okay, meters or centimeters. What is it given in the question? You are going to write that. Okay. So is it understood? Is all of the concepts still now cleared with you?
Yes.
Okay, that's great, mashallah. So we'll quickly move to the arc part. We almost have it's not just, it's 20, it's 10 to 15 minutes we have. Inshallah, we'll just cover the part. The next part that we're going to see is nothing but arc. Do you know what is an arc, Laiba?
Yeah, I know.
What is an arc, beta? Okay, I'll tell you what is an arc is. If you draw a chord, okay, if you draw some line like this, or even if you draw some line like this, okay, but the two endpoints are on the circle, right? Or if you draw something like this, okay, see something like this, okay, the part that are formed by the 2 points on the circle is called as the part, okay, we are just seeing the part here, is called as an arc, okay. For the first time being, let's just consider the first chord that we have measured, okay. For this chord,
Arc is part of the circumference.
yes, but it's a part of the circle formed by the 2 endpoints of the circle, okay. I'll tell you how it is.
Yeah.
This is an arc. This is an arc, correct? It is a part of a circle. So this chord subtends 1 arc and 2 arcs, right? This arc is called as a minor arc, which is a small part of a circle, okay? This is called as a major arc, which is the most part of a circle, correct? Understood? Yeah. Okay. If you have another circle here, Laiba, and if you're going to draw this one, do you have major and minor arc here? No, but you have arcs here, 1 arc and 2 arc, correct? These 2 arcs are nothing but they form semicircles, correct? It is nothing but part of the circle. This part is called as 1 arc and this part is called as another arc. Fine? Fine with you? Any doubts still here? So what is an arc? It is nothing but a part of a circle. It is formed by 2 endpoints meeting, however it can be. So if you have these 2 chords, if this chord is here, then this forms a minor arc, this forms a major arc. Fine? If you have a circle, and if a point is in this way and this way, then does it not touch 2 points? Yes. So this is an arc, correct? This part is also an arc, correct, beta?
Yeah.
Yes, even this part is also called as an arc of a circle. Understood? Any doubts? It is part of a circle between the chords or between the 2 endpoints. Fine?
Yeah.
It is a part of a circle between the chords. It is a part of a circle between this chord, this part, and this part is called as an arc. Part is nothing but arc is nothing but a part of a circle between the chords or the 2 endpoints of the circle. So endpoints of the chords of a circle, endpoints of the chords of the circle make 2 arcs, right? Fine? Fine?
Yes.
This chord makes 2 arcs, right? 1 arc here, 1 arc here, right or wrong? If you draw one chord in a circle, it makes 2 arcs, 1 arc and 2 arcs. There's 2 parts of a circle. Is it not, right? Yes. Understood till here? Arc is nothing but it is a part of a circle which is subtended by a chord. So endpoints of the chord of a circle cuts the circle into 2 arcs. You have to remember this, okay? Endpoints of the chords of the circle cuts this circle into 2 arcs, 1 arc and 1 arc. This is minor arc and this is major arc. Fine? Fine or no? Understood? Yes. But what if you have equal chords? If you have 2 equal chords, 1 chord here and 1 chord here, what do they do with it? Do they not cut it into again equal arcs? Yes. If you have 2 equal chords, for example, you are going to draw 2 centimeter length of chord here and 2 centimeter length of chord here, it actually cuts it into, this cuts into the minor arc, same, this minor arc and this minor arc will be equal, and this major arc and this major arc will be equal. So equal chords cut equal arcs in a circle. This is an important theorem that you have to remember. Equal chords of a circle, they correspond the equal arcs or equal arcs in the circle. Okay? Equal chords give equal arcs. Okay? Are you listening?
Yes.
Yes. So equal chords subtend the equal arcs. You have to remember this. Equal chords give you equal and congruent arcs. This is an important property of the circles, that equal chords give you the equal arcs. Fine. So this is a circle. If you have 2 equal chords, then it actually gives you the 2 equal arcs. So this arc, this part, and this part are equal. Correct, beta? Because AB is equal to CD. Fine. And even the major part here, this part that is subtended by AB, and this part from the DC to this one is equal. Okay, the major arc and the minor arc are equal if the chords are equal. That you have to remember. Okay.
Yes.
So this is one of the property of the circle. So then there's another property: congruent arcs of a circle subtend equal angles at the center. Okay, this is another property of the circle, which is same as the theorem number 1. What did theorem number 1 discuss? What did we discuss in theorem number 1? Can you please tell me? Is it not the angle that is subtended by the equal chords equal? Yes, right?
Yes.
So if you have the circle and if you just draw 1, 2 points, then this arc subtends equal angle. Okay, these two arcs, if you draw two arcs, they actually subtend the equal angles at the center. Okay, so this property, the first property here about the arc, there are two properties discussed. One is the equal chord subtends equal arcs, correct? And the second property is congruent arcs or the equal arcs. If you have two equal arcs, they subtend equal angles at the center of the circle. Okay? Okay?
Yes.
Understanding this concept?
Yes.
See, if you have this arc, this is an arc, right? PQ is an arc. This PQ is an arc. If you have some equal arc here, let it be what we can write as CD. Okay, this arc subtends actually the angle, this one, and this arc subtends angle POQ, and this subtends DOC. So DOC is equal to angle POQ. These are the two properties, okay, in the chords. The first property is nothing but equal chords give equal arcs, correct? Equal chords give equal arcs. Fine?
Yes.
Equal chords give equal arcs. If you have equal chords, two equal chords, they actually give you the equal arcs. This arc and this arc are equal. This arc and this arc are equal. So equal chords give equal arc. And the second thing is equal arcs subtend equal angles at the center of the circle. This is the same as theorem number 1. Okay? So these are the two properties that you just have to remember. You will have some problems in this. Okay? You will have most of the problems regarding this. Okay? So we will see the theorem based on this concept. Okay? It is nothing but about the angle subtended by the equal arcs at the center of the circle. We just have 5 more minutes. Inshallah, we'll finish this theorem out, and you're going to write this theorem and come for the Monday's class. You have to memorize this theorem for the next class. Okay? So if you have this circle, beta, okay? Laiba?
Yes.
This is an important theorem. If you have a circle and if you have subtended some arcs, if this chord subtends some angles, okay, what did we say? It subtends equal angle at the center, right? If you have equal arcs, then it subtends equal angles in the center. Now the next thing that you're going to study is, if you have a circle, okay, if you have a point, okay, if you're going to draw this arc, fine,
yes,
to the chord. If there's an AB chord, and this is an arc, right? This whole part is an arc to the center of the circle. AB is an arc now. Okay? Okay. The angle subtended by this AB, what is it? AOB, right? Arc AB is AOB, correct?
yes,
Yes. If we draw something here, B, named B, or let's try, if we draw a dot named C, okay, let us name C, and we are going to make another angle. Let's subtend another angle by this chord AB, by this arc AB. If you have arc AB, let's subtend two angles. One is AOB, one is ACB. Now the main angle that is at the center of the circle, AOB, remember this, it is actually the twice of angle ACB. This is one unique property of the arcs. Okay? Fine, beta?
yeah,
AOB is 2 times the angle ACB. So this is isn't this a large angle AOB? Yes. So this is 2 times of the ACB. This you have to remember. Okay? This is actually the theorem number 8. Is it 8? Or theorem number 7? Yes, theorem number 7. So the angle subtended by an arc at the center, just now what I have told you. Okay, the angle subtended by this arc AB, let it be AB, at the center of the circle. Is it not AOB? Yes, the angle is AOB, correct? Fine, beta. This is double of the angle subtended by it at any point on the remaining part of the circle. Fine. If you draw any point here on the remaining part of the circle and just subtend another angle from here till here, then this angle will be half of this major angle. Fine. Understanding this? Yes or no, please?
Yes.
Yes. Yes, so angle AOB will actually be 2 times as much as an angle ACB. This is what you have to prove in this theorem. Okay, for this theorem we are going to consider 3 major diagrams. Why are we going to consider 3 diagrams? Is because it's the same. All of these diagrams are actually used as a hint for you. You can draw any one of these 3, or you can draw all of these 3. Okay, because if PC is a major arc, if this PC is an arc, okay, if you have POQ, okay, beta?
Yes.
What can we infer? POQ is 2 times of PAQ, correct? Yes, right or wrong? What we have to find? It is not POQ is equal to 2 times the PAQ? Yes or no? POQ, angle POQ is 2 times of angle PAQ. So angle POQ is equal to 2 times angle POQ. This is what we are going to prove now. Okay. So what we are going to prove, it is nothing but double the angle subtended by it at any point on the remaining part of the circle. Any point, matlab, we are going to show another point here. So if this is an arc as the semicircle here, then if this one is an angle subtended here, this angle POQ again will be twice of the angle PAQ. Here again, if we have this arc here, PQ, if we have this arc here, then this angle POQ is twice of the angle PAQ. Okay? This is important for you. We are going to prove this theorem. It is quite easy to prove. It is nothing but, first let's start. Let's just consider any of these 3 triangles. It's better if you write 2 of this or just 1 of it. Okay? If you write 3 of it, then it is excellent. Please write 3 of it in the exams if they ask you this question. Okay? The proof is very simple and easy. What you're going to do is you're just considering, let's consider the first figure. Okay, do not get confused. Let's consider the first figure. Okay, beta?
Yes.
Yes. Now we are going to draw some line here. Okay, some line here. So if we draw this line and just consider the triangle AOQ, okay, we're just considering the triangle AOQ, and let's consider this is an exterior angle. What is BOQ? Is it not exterior angle to this triangle AOQ? Yes. So what is BOQ now? BOQ is exterior angle. If BOQ is an exterior angle, how can we get these 2 interior angles? Sum of 2 interior angles is equal to exterior angle, right? So exterior angle of a triangle is equal to the sum of 2 interior angles. So what is angle BOQ now, please? Is it not OAQ plus OQA? Yes, right? Angle BOQ is equal to OAQ plus AQA. Why is it so? Because exterior angle of a triangle is equal to the sum of 2 interior angles. Okay? Clear till here? You're just drawing the diagram, considering this figure, and you're just drawing this angle. One exterior angle is here. To get the exterior angle, to get something from the interior angles here, we're just going to add up this 2. Okay? What is this? Angle BOQ is equal to OAQ plus OQA. This is considered now. Okay. Next, what we are doing here is we are just going to do something that we are going to get it as a 2 times of something, right? 2 times of something. To get 2 times of something, what we are going to do is I'll just maximize this so that it will be easy for you to understand. Just a second. Okay. So if we have triangle OAQ, where is triangle? This one, right? Where is it? Okay. We just consider this one at first. It is nothing but BOQ is equal to AOQ plus, what is it? AOQ plus? Sorry, it's not OAQ plus? Yes, OAQ plus OQA. Okay, this is the first thing that we have considered. Exterior angle is equal to sum of interior opposite angles. Next thing what you're going to consider is OA. Is it not OA is equal to OQ? Yes. Is it not the radii? Yes, Navita?
Yes.
OQ is equal to OA. Is it not the radius? Yes. If the radius are equal, we had theorem 5 in the triangles. What was the theorem 5 in the triangles? It states that if the opposite 2 sides are equal, then opposite angles are also equal, right? If two sides are equal, then the angles opposite to the equal sides are equal. Correct? Angles opposite to the equal sides are equal. So what is equal to what? OAQ is equal to OQA. Fine. If OAQ is equal to OQA, can we not apply this in the statement that we have given at first? What was the statement that we had made? OBQ is equal to OAQ plus OQA. Is it not right? Yes. OAQ, instead of OAQ and OQA, can we not write as just 2 times OAQ? Yes, right? So
Yes.
OBQ is 2 times OAQ. Why is it so 2 times OAQ? Because we have just proved this is a radius, this is a radius, this and this angles are equal. So OBQ is equal to 2 times the angle OAQ. So OBQ or QOB is nothing but 2 times OAQ. And also in this triangle, if you take for this triangle also, you will get POB is equal to 2 times something like this. 2 times which one, beta? OAP. Okay?
Yes.
Fine. So we have got this one now and this one now. What are we going to do? We are going to add equation number 1 and equation number 2. If you're going to add equation number 1 and equation number 2, you will easily get the equation that we had that you have been asked to prove. It is nothing but if you add BOP plus BOQ on this side and then this 2 times this one and this side, you will easily get the answer POQ is equal to 2 times angle PAQ. This is your final answer that is being asked. Okay? Understood? Any doubts in this theorem? So this is the theorem number 7. So you're going to write the theorem number 7 and come to in the Monday's class, inshallah. So you have to just memorize theorem number 7, fine? So this is the homework for tomorrow's class. For